Good day, I am Joanna Marimata and today I will present my experiment which is entitled The Efficacy of Bamboo as a Resonance Chamber. Sound is produced when there is a sound source and a medium. As the sound wave travels, energy is lost. Resonance is a common source of sound in musical instruments. Example is a hollow cylindrical tube partially filled with water and forced into vibration by a tuning fork. However, in the absence of resonance, the sound of these vibrations is barely audible. In this paper, the efficacy of bamboo as a resonance chamber will be studied, comparing the sound level difference with and without it. Hence, this paper believes that bamboo amplifies sound and produces desirable acoustic properties compared to open space. This paper is grounded on the following objectives. First, construct a bamboo resonance chamber for a cell phone. Second, perform 10 trials to determine the sound level produced with and without the bamboo resonance chamber. Third, calculate the gain of the resonance chamber and express it in the decibel unit. And last is determine the efficacy of bamboo as a resonance chamber. In this experiment, we will need bamboo, saw, knife, pencil, electric drill, sandpaper, cloth or dust remover, paintbrush, paint varnish, shoe glue, and sound meter. Here are the procedures of the experiment. This is how I made my bamboo resonance chamber. This is now our finished product. Now let's go to data table, graph of the data, and data analysis. From the table, we can compare the sound levels produced with and without a bamboo resonance chamber. Calculating the mean and gain will help us determine the difference of sound level produced by the two variables. To collect the data, we conducted 10 trials with a cell phone volume of 50%. Let us look into further details their differences. Figure 1. The sound level produced with a resonance chamber goes around 84 decibels to 86 decibels, which shows a high radiation coefficient. After 10 trials, we added the sound levels produced in each trial and divided them by 10. Hence, the mean is 85.3 decibels. On the other hand, the sound level produced without a resonance chamber goes around 80 decibels to 83 decibels, which shows lower volume compared with a resonance chamber. After 10 trials, we added the sound levels produced in each trial and divided them by 10. Hence, the mean is 81.6 decibels. To check the efficacy of the bamboo as a resonance chamber, we calculated its gain. The gain after 10 trials goes around 1.02 decibels to 1.06 decibels. After that, we added a gain in each trial and calculated the mean, resulting in a mean of 1.05 decibels. From this data, we can infer that the bamboo resonance chamber produces louder sound than without it. Hence, the bamboo is effective as a resonance chamber. Figure 4 shows the relationship between the volume produced with and without a resonance chamber. The graph showed close intervals between the sound levels. However, the bamboo resonance chamber amplifies the sound from the cell phone. The mean of the two variables, which is beyond 4 decibels, showed a significant sound level difference. It also means that confining the sound waves in one medium allows the particles to vibrate faster as they travel shorter distances compared to open space. The efficacy of bamboo as a resonance chamber was supported by Aditanoyo and Presiteo and Putra 2017. Their study revealed that the morphological characteristics of bamboo show desirable acoustic properties. The performance of bamboo as a soundboard has a high sound radiation coefficient, meaning high sound is transmitted by it. Hence, the theory presented in this paper was proven to be true. Based on the aforementioned results and findings of the experiment, the following conclusions were formulated. The mean sound level produced with a resonance chamber is 85.3 decibels, showing a loud sound like a busy street. The mean sound level produced without a resonance chamber is 81.6 decibels, showing a lower sound compared to the sound produced with a resonance chamber. The gain of the resonance box is 1.05 decibels, showing its efficacy as a sound amplifier. If the gain resulted in 0, then it means the resonance chamber does not amplify the sound from the cell phone. The graph showed that the sound levels produced without the resonance chamber do not equate or exceed the sound levels produced with the resonance chamber even once during its 10 trials. The data revealed that bamboo is effective as a resonance chamber and produces desirable acoustic properties. However, a louder sound can be amplified if the bamboo resonance chamber is bigger. Based on the data analysis, the following statements are recommended. The students can use this paper as a guide in making a bamboo resonance chamber and support for a relevant experiment in the future. The students may also design their bamboo resonance chamber according to their preference. And future researchers can use these findings for more enriched research about the efficacy of bamboo as a sound amplifier.